Hi, my name is Joby Bednar. I'm creator of Video Vector, and I'd like to show you what it can do. So we're going to start Video Vector here. Version 1.1 has a very simple interface, basically four main sections. There's the text editor itself, there's the rendering scene, there's the post-processing and rendering filters, and there's a timeline with the ability to save and export videos. And so when you load up the application, there's this default scene that comes in. And as you can see, process scene text to render preview. Either you click this button every time to process this text, or you can do command return. I'll just click this button here. So now there's the scene, and you can collapse these down if you want to just look at the scene and deal with it. It's on a timeline. It does have a basic animation, and you can step through different times and frames. You can play and pause. There's abilities to increment and decrement frames by frames using the keyboard, shortcuts. So there's a number of things you can do to review what you're working on. As you can see, there's some shadowing going on that varies as you rotate around, but this is a basic scene, and what it does is it allows you to initially see how this whole system works. And so this is the basic language that you're going to be working in Video Vector. It is a text-based text file system in which you're defining the three-dimensional scene and elements purely in code and in line in this kind of cryptic language that I've developed, but it's very concise and very dense. Some of the notation, lines and dots, very similar kind of concept to OBJ files of vertices and lines and vectors, I mean faces, and so it's very common. In fact, there are ways in which, if you do this generate, there's a I call it Spider Graphics ASM. It's an assembly-like language in which you can build turtle graphics. If you ever used logo turtle graphics back in the 80s, it's very similar to that, but it's in three dimensions and it has a assembly-like structure to it. This language you can learn more about, but you can generate three-dimensional objects that way. The other thing you can do is you can import OBJ files. There's a specific way that you want to kind of thin them down so that they're compatible, but it's good for doing basic geometry and pulling them in. These systems that I have, these conventions, there's certain conventions like this right here, these colon and then sphere and then some parameters, that's generating this sphere here. And as you can see, it's very condensed. The only thing it's defining is that you actually are wanting to create a sphere, and it's got 10 segments down, 10 segments across, a radius of 2, and then these are the definitions for how to color the lines and faces, and then the line width itself. So all of this is a little cryptic, but in the app, the user has this very extensive scene reference guide in here with all of these details, all of this notation spelled out. Here's the colon notation, and it talks about how there are geometry presets and how to use them and some examples. There's a whole section in here of the different types of presets that are available to you to use. And so we can take a look at, sphere and see the information about the segments, the radius, how to use it, what exactly they are, the limits of it. So, really great guide for understanding and learning. So highly recommend that. It is a window that stays above as you're working in here. So you can always, if you're working with two monitors, you can always keep it open. The other thing that you can do to help understand what's going on is you can graph equations in here. And so everything, the very foundation of video vector is every scalar, every value can be an equation itself. It can be an expression. So this is the notation for keyframing the movement of the axis here. The angle of rotation is about the z-axis. So that is why it rotates and spins this way. And it's rotating tau times nt. Now again, you can look at the documentation here for what these variables, all the variables that are available to you, but time and nt specifically is a normalized time, 0 to 1. And so this tau times nt is basically from 0 to 1 as far as the video length itself. It makes one complete tau numbers of rotations. Rotations are in radians. So you can create equations to do these types of animations really easily. And the thing that you can also do, as I was saying, is graphing, is you can register them to be graphed with a $sign. And then when we reprocess this, you can see it change color. But now, since it's registered, you get a graph of what it's doing. So it's going across the entire video, and you can scrub the timeline and see what the value is of things. So that tau times nt at, well, actually, if we make it pi number of seconds, it's going to be roughly a whole number. But anyway, so you can graph it, you can see, you can scale the graph, which doesn't look very interesting on a straight line, but it helps you visualize what's going on. And so these are the tools of video vector and how you can export video assets. There is a tree-based mode that you can go into where each one of these things are individually highlighted in a tree-like structure. More common in a lot of other 3D programs has a tree hierarchy. However, there is this raw mode that I think a lot of people will appreciate and use instead. This is the notation for childing the geode to the axis, which translates to placing the geode under and childed to the axis. So they're very similar. You can do everything is straight in the text file. You can load and save other types of text files. So let's just load up. I did a circle grid here recently. And so you can see here is the code for generating the circle grid. Generates a circle, however, it's broken up into grid segments. And with this equation for the coloring of the faces, it's grouping the faces in such a way that it creates banding across the grid itself. So there's a lot of different ways that you can play with this. We can do things like IDX is the index number of the grid itself, and so let's break this up into 4. Oh, actually, let's divide by 4, and there you go. So you can see that the triangles of each of the faces. There's 2 columns of faces. There's 30 segments of faces. Let's break that down into 10. And so you can see it's really easy to play around and edit these things very quickly and easily. Now, when you've got something that you like, the other thing that you can do is then adjust the post-processing. So we can increase the pixel size and bring it into old school graphics. We can really crank it up and start to get into something that's like a Atari 2600. And we can add in, let's add in some motion to this so we can see it a little bit better. I'm going to do keyframing. And I'm going to start, let's use position itself. So this is notation for position. This is no position changes whatsoever, but let's do Y. Let's make it the sine of tau times nt, and so that'll make one complete revolution. As you can see it kind of bounces up and down. It's not very big, so let's take that whole thing and times it by 3. And now as we play, you should be able to see it. Yeah, rotate up and down. We can drop that down so you can see. So you can do some real quick and simple animations very easily here, but there's some different options. We can bloom. That's with a bloom filter here. We can create like a little play around with it and change its qualities. There's different types of, there's edge grime. You can see that you can do that. You can do both of them. And these are sortable, so we can put that into a different order and see the grime. And so there's different type. There's a 3x3 pixel convolution. Let me drop this out of the way. It's 3x3 pixel convolution that you can do, and it's got a lot of iterative effects that we can do. We can apply multiple times, and let's just do by RGB channels, and let's just affect the green channel and do edge detection on the green channel alone. It's not really doing much. Very noticeable there. Let's actually go standard and do edge detection. Try. Oh, I have to activate it. so let's go back. Let's revert that. Let's go back to just the channel and the green channel and do edge detection just in the green. Oh, it's got it saved. So you can create all sorts of fun effects and layering these in different ways. We can convert it to ASCII very easily. There's a dithering function. By default, it dithers into the original Mac palette, but I also have classic Bayer dithering effects, or 4x4 and a 2x2 grid dithering. So just some basic post-processing filters that I've included. There's abilities to load in an audio source, and that allows you to bind a song or various audio to this image. The length of this, currently it's 10 seconds. This is the dimensions of the screen, the time, and the frame rate. It expands the time out to the length of the music, and you can you can create a graphic equalizer. You can tie into various aspects of the audio. Video source, you can have a video in the background with the audio track that you can connect into. And data tracks, you can load up a text file that is a keyframed set of data in which you can control all these different aspects. And I could save this off if I take this, and we'll just re-register it real quick. I should also mention that we've got a bit of a editor here, which tells you if there's an error, which this is an error because when you register, you need to wrap it in quotes. So recognizes that. Now in here, you can export this data as a data track. And so if we export that, let's save it. Let's just do the output. I had some unit tests going on here. We have a graph track that we can do. Let me pull up. Oh, let me drop that down. And let's see. Output, unit tests. Okay, graph track. So as you can see, what it did is it generated it. And it generates a value per frame, so we can load this in and control it that way, and you can optimize the data. So it's very powerful, very flexible, and there's a ton of stuff that you can do with this that's really fun. Let me load Fractal Flyer. That's kind of a fun one. So this is I'm post-processing it too, so let's get rid of that. And so this is a real fun fractal kind of flyer that you can create. I've got this little, so this isosphere, this is the ship itself. And this is the notation for adjusting the background. The background you can control very similar in a way to a pixel shader, but this is the code that is creating the Mandelbrot fractal. And so there's a lot of built-in functions that I've done. And again, you can look up all the different types of functions that are in here. There's some, procedurally generated noise and some various fractals that you can develop and see. And you can attach that as the background, and it's a lot of fun stuff. And so you can come in here and adjust the ship's line width. It's 5. Let's drop that down to 2, so it's a little easier to see. But we can scroll through here. We can create our little video. You can tie it into some music as you want as it dives into the fractal. Lots of fun stuff here. But saving, you can save the PNG. I'll just save this off real quick, and you can see that, lost track of what I was doing. So it can save off the image as a full PNG of the full size. Now this one, before the default scene is 640 by 480. I've got it full HD right now. So you can do that, export the movie. I'm not going to do that. It's going to be a little too time consuming here. But just lots of fun stuff that you can do in this app. So let me show you some of the additional settings. If you go into the app settings itself, the editor itself is color coded. I call this Lucky Charms. It's kind of got a cereal, milk, and marshmallow kind of colors going on. I have a lot of fun, different types of color schemes you can play around with. War games. There's Backrooms is kind of a fun one, very popular. Inferno. I like Yacht Rock also. It's got a cool pastel vibe going on. But you can do that. You can define the default scene text to whatever you want when you're loading to start. And maybe, this is a series of equations for world lighting and allow you to attach lights, quote unquote lights. It's a very simple graphic engine. You're only defining the colors of lights and faces. And so this is a way to simulate lighting. But you can create whatever functions that you come up with, that you devise. You can create them as your default. There's a list of shortcuts of everything that that you can do with it. And export. We can export into a number of different MOV files. It exports MOV codecs, I should say, not files. If you want to preserve transparency, now that is the default, and that does. As you saw with the initial scene, it actually had a checkered background. It is transparent, but if I get rid of this, actually, let's just comment this out. You can see that we've got our flyer against a transparent background. I can export this video itself just as a transparent background, allowing you to use this as video assets for your own video art. You can layer this in whatever video editing program you use. You can layer it in on top of your stuff. You can create multiple videos. I could take this, export it as a video, load it as the background, and then add new geometry on top of that, and you can save that as a video, load that in as the background, build more geometry. You could do all sorts of really fun stuff each time, going through a graphics pipeline, post-processing, lots of fun stuff that you can do in this very easily and quickly. And so I'm really proud and excited about that. And you can save it off in a much more compressed format, much smaller file size, but got that. There is a debug setting. If you turn it on, it'll give you some breakdown of debug information here as it's playing along. You can see how fast it's processing everything. If there's any issues, something's super slow and it shouldn't be, screenshot this and send it to me and I'll look into it. But I added that just to see, to help me debug stuff in the future. Now, the big thing that this has that I'm really excited about is that you can register agentic AIs to leverage Video Vector. And just to be clear, the AI does not, there are no AIs within Video Vector. It's a very small app. It's The app itself runs off of pure Apple architecture. You can see it's extremely small. There's not much going on in here. But what it does is if you use an agentic AI, there's a thing called the MCP protocol, and you can register MCP servers with your agentic AIs, and they can connect to those servers and access the services of software. And so the agent can then control and look at the text, the scene text here, and it can update the scene text, and it can help explain what's going on. It gets a full library. It gets all of this information that's in the scene reference guide, and so it can tell you if you have questions of like, how does this work? How is the coloring working? For rendering this, it's not working for me. What would be a good way to format these equations? Let's change the color of the flyer. How is this an isosphere but it looks heart shaped? How does that work? So you can ask it these questions and it'll analyze the scene coast. It'll update the scene coast, scene text, I should say. And so it's really useful when you're coming up to speed and learning this app. What you have to do is you have to register this with your with your agentic AI. So when you activate this, you'll see there's a little MCP signifier here. It gives you detailed instructions on how to actually register it. I've got codec here, OpenAI's codec. There's a section in the settings for MCP servers. I've registered Video Vector, but what you do is you have to, there's a standard IO helper app that's bundled within Video Vector. It's under some subfolders, and this MCP helper is a standard IO app that your agentic code does command line interfacing with. This agent helper, what it does is it communicates to Video Vector across an HTTP service that it is now running, and that's what this does, is that it's now been enabled in service. Now, if you close this app, I'm gonna quit this app. If you close this app and then open it back up, you'll see that it's no longer active. And if we go into the settings, it's been deactivated. This is only active while you're actually running the app. It shuts itself down if you turn it off during that session. You physically have to activate this for every single app session. So I'm not making this automated in the background. This is completely under your control. And so again, there's no AI actually inside this app. This is simply a protocol in which other agentic AIs are able to connect to it. And so let me just turn it on and let's see if we can play with. So it's now running. It's now active. I'm gonna load up this. So this is just the default scene text, and this is the lighting of the faces. They're purple. This is a function for the shading of the purple, but it's effectively purple with the way that this is working. So let's try to get the agent to work with this. So let's see, using Video Vector MCP, change the color to yellow, so you can kind of get an idea of what's going on. Now this may take some time. It needs to connect to the scene, figure out what's going on, download the instructions to understand how this scene text is configured, so it can figure out what's the sphere and how the color systems work. So you can see it actually is defined. It found that it's defined within the geode object. And so, we need to do some approval here. What is it? Let's see. What does it need to allow it to replace it? And so you can see here's what it is trying to do. So let's allow it. And then it discovered an error that it didn't do quite right. Let's allow again. There we go. So it changed, actually it changed both the lines and the faces. I should have specified change it from purple to yellow and it would have found it better, but you know, it was able to do it. So it changed it. Now let's ask it, you know, how does the lighting work? And so now it's going through and it's analyzing what we've got here, and it's actually breaking it down into the various equations, telling you how it's structured, the RGB values. You know, so this is a fantastic tutor that you can use when you're coming up to speed for using Video Vector. I highly recommend it. It's really great. It's now you can ask it to do some pretty, you know, fun stuff. It's not the greatest at, you know, generating complex objects, you know, but it's incredible at actually explaining what you can do and showing you some examples of things for you to come up to speed and learn how to use it. So anyway, that is really the extent of Video Vector and the kinds of things that you can do with it. And you know, I hope you have fun using it, and that I'd love to see the creative stuff that you've got going on. And you know, let me also mention in if you need any help, there's a Discord in which you can join and share your stuff with and get questions. I'm on there and will answer any questions you have. There's the website and also another app that I have that you may want to discover. It's also on the Apple App Store called Video Barbershop for editing videos. Once you've generated your video asset art, perhaps you want to take a look at my video editing app and see all the fun and powerful stuff that app can do. Okay, so thanks so much. This Video Vector is currently, submitting it to Apple. Hopefully it should get approved soon, but this is the basics of what Video Vector is and how to use it. And I hope this is exciting to you. This has really been a childhood dream of mine ever since I had an Apple II Plus, to be able to just simply type out some really small, short, simple lines of code and create, you know, incredible 3D worlds in a really fun kind of low-res graphic environment, similar to the types of computers that I had, you know, as a kid in the 80s. And so I'm really excited to have this out in the world. Thank you so much for the interest in it, and you know, please do share and hit me up if you have any questions. Okay, thanks.